Okay, so we are just going to look at some additional examples of using SohCahToa, our trig ratios, to solve for missing sides in a triangle. Okay, so just kind of, if you're having some issues, this might be some additional notes and examples to look at. So let me go ahead and share my screen. I'm using the notes packet. And I'm going to do the other examples in 3.3. Okay, so you've got your notes packet, you can follow along. If you don't, you can just copy this onto scratch paper. All right. So looking at this is example 5 and example 6. So in this one, we have two sides that we're going to be looking for, and they've given us one side and we have an angle. So just as a reminder, we have to first determine when we're solving for a missing side, we've got to determine where is our reference angle, because that's going to make a difference. So here's my reference angle right here. And I need to first identify which side I'm looking for. Okay, let's say I'm looking for A first. Now, when I say identify, we need to know, is this the opposite leg, the adjacent leg, or the hypotenuse? And in this case, in reference to 31 degrees, this is a leg because it forms that letter L, forms the right angle, and it is adjacent. It is the whole side is next to my angle. So this is an adjacent leg, right? This is adjacent, but it's not a leg, okay? So this is my hypotenuse. And that's the side that I'm given. So I always try to, I use this to determine which trig function I should use. So I see that I have an adjacent and a hypotenuse, A and H. I'm looking for A and H. I don't see A. Here's A and H. So this tells me to find A, this variable A, I need to use the cosine of 31 degrees. So the cosine of 31 degrees, because of this A, this H, and here's an A, and here's an H, equals the adjacent, right? It's adjacent over the hypotenuse. Well, in this case, my adjacent is my variable A, and over 45. Now, remember that, I'm just going to rewrite this. Remember that when we are solving a proportion, if it's helpful for you to make that like a fraction, I am going to cross multiply. So 45 times the cosine of 31 degrees equals A times 1, which is just A. Notice A is all by itself, so I'm ready to use my calculator. Make sure that you are using degree mode in your calculator. Anytime that you use the TI-84 on the computer, it's generally going to go to radian mode, so it's always a good practice to get into the habit of it. If it's something that's like on Edulastic and I use a calculator, I give you that function. Anytime it's reset, it's going to put it in radian mode. So we just need to make sure that, notice mine was in radian mode. I need to make sure that I change it over to degree, right? Because that is one of the easy ways to get a wrong answer, even though you're doing their math correctly. So now in my calculator, I need to type in 45 times cosine of 31 degrees, and I get 38.57. It doesn't tell me what to round this to, so 38.572, I'm just going to go 2 decimal places and round this down to 57. Okay, if I was going to the 10th, I'd round that 5 up to 6. All right, so here was A, for side A. Now, if I want to find side B, notice that this B, this side, is a leg. It's not the adjacent leg because it is all the way across from my reference angle, 31 degrees. So this is the opposite leg. This is still the hypotenuse, right? It's only legs. The only thing that changes is the opposite leg and the adjacent leg. The only time those change is when we change positions for our reference angle. So if I'm looking at this one to find B, since I have the opposite, which is an O, that's going to say, okay, well, that's got to be either sine or tangent, because that is, they'll both have an O. But the side that, and I have a tendency, since I rounded, I don't really want to use that side. I would rather use the one that was given. So since this one is 45 given, that's a hypotenuse. I can't use tangent, so I'm going to use sine. Okay. And in this case, sine of 31 degrees equals my opposite, which is this case b, over my hypotenuse, which is 45. And this is going to be set up the same way this one was. Notice when my variable's on the top, all I'm doing is essentially undoing that division with multiplication. So 45 times the sine of 31 degrees equals b times 1, which is b. And now I can type this into my calculator. And pretty much we are going to have to use a calculator. It's 23.176. So as I look here, that 6 is going to have me round that 7 up to 8. All right. In this next example, and this is kind of what we're going to be doing some practice with, thinking of some real life situations. We have a flagpole. It's standing in there. We're 50 feet away from the base is a surveyor measuring the angle, right? So here's my flagpole, assuming that it forms 90 degrees. And we know that 50 feet away on the ground is this guy standing here. So this is 50 feet. And we know that the angle measuring up to the flagpole is 48 degrees. So, all right, that's 48 degrees. And now we're trying to, here's my picture. If we're thinking about, you're talking about a right triangle. So just think about what we're looking for. Here's the 50, there's the 48 degrees. We don't really have anything else. We know that this is basically the line of sight, right? If you imagine little daggers going out from where the line of sight is coming up to the top of the flagpole. And then this would be the height of the flagpole. So I'll put H for that. All right, we're looking for how tall is the flagpole. So we're not looking for what's the line of sight, right? We're looking for how tall is the flagpole. So we're looking for, let's go ahead and identify, in order to figure out, are we using sine, are we using cosine, or are we using tangent? I need to identify which two sides do I have in my triangle. So here's the reference angle. Notice I have the two legs. So I have the opposite leg and I have the adjacent leg. Okay, O and A. So here's my O, here's my A. So O, okay, but that has an H, so that's not good, and O and A. So this is the only one that I can use. Tangent of 48 degrees equals, it's always written as a fraction. This is the numerator, this is the denominator. So my opposite side was H, my adjacent side was 50. So in this case, again, our variable's on the top. It makes it a little bit easier. We're going to do 50 times the tangent of 48 degrees equals the height. It didn't ask us to round, so we don't need, we're going to have a crazy decimal, but we don't need to, we can probably round to 2 decimal places since it didn't say anything else. And I get 55.530, so I'm going to round that down. And we know that this is in feet. Okay. So then we can find, we can use that to find our height. All right, so roughly 55. If they said rounded to the nearest whole number, I'd round up to 56. Okay, so as you're looking at some of these, I think there's another practice one here, right? Calculating the height of a rocket. We're going to move 100 feet from the launch site, so we kind of have a picture here. We have this angle of elevation, right? It's not going straight up. It's going at somewhat of an angle. And then they're just kind of saying, what's this highest point? We know here's this. And we're trying to find the value for the 3 flights are given, find the height at each of those angles. Okay, so we essentially, we're standing in the same spot, but we've changed the angle, and we're going to see how does that change the height. So when you're thinking about this, writing your, and this is not to scale, right? There's 77 degrees, that's 100. We're doing this essentially 3 times. Here's 81 degrees, that's 100. Then I made it 83 degrees. How much is that going to change it? How is that going to affect this? Well, every time when we're looking for this, notice I'm looking for the opposite side. I have the opposite leg, and I have the adjacent leg. So does not work because that does not have the adjacent. Ka doesn't work because that doesn't have the opposite. So toa, tangent, opposite and adjacent, opposite and adjacent. Okay. So the only way I can set this up, tangent of 77 degrees equals the thing I'm looking for, the height, the opposite leg, over 100, the adjacent leg. In this one, it's the same setup, just the numbers are slightly different. Okay. Okay, so every time, notice that when I'm going to cross multiply, right, we end up with just 1 times our variable, so that works out nicely. And then the side times the trig function. So 100 tangent 77 equals my height. In this one, it would be 100 times the tangent of 81 equals my height. And in this one, so let's figure out what happens as our angle gets a little bit bigger, right? Does our height go higher or does it go lower? So as we're looking at this, 100 times the tangent 77, if I'm rounding it to the nearest foot, 433.14, it's going to be approximately 433 feet. If I do 100 times the tangent of 81, now all of a sudden it goes up to 631 feet. So notice just 4 degrees made such a huge difference in our height. And then if I'm just looking at 2 degrees, let's see what happens there. 100 feet times the tangent of 83. Notice I went 814.4, so that's about 814 feet. Okay, so as we're looking at this, notice that, the closer I'm getting to 90 degrees, the higher this thing's going to go up, because 90 degrees would have the thing going straight up. So this is, the longest distance is kind of that hypotenuse right there. If I go straight up, there's no hypotenuse. So when we're thinking about this bigger angle is going to cause our height to go a little bit higher. Now, if I were to start changing it here, once I go past 90, then all of a sudden it's like a triangle going in the opposite direction and things are going to change a little bit. So you can see that just a couple degrees can make a huge difference in what kind of numbers you're getting on that triangle. So this is some good practice. Make sure you're doing this. You should feel comfortable identifying which trig function to use to solve for a side. You should feel comfortable identifying the sides of a triangle and given a reference angle if you have the opposite leg, the adjacent leg, the hypotenuse. And you should feel comfortable solving some of these equations for what we are looking for. And one thing I'm going to just kind of set up, I'm just going to look at this one because here for S, because all of ours have been, the variables been on the numerator. If I'm trying to find S, okay, notice here's my reference angle. Here's the leg that's opposite it. And S is not a leg, that's the hypotenuse. So I have O and H, that tells me so for sine of 36 degrees equals my opposite over my hypotenuse. In this case, when my variable's on the bottom, when I think about that cross multiplying, I get S times the sine of 36 degrees equals 21 times 1. Notice S is not by itself. We don't have S equals, so I can't just, put this into the calculator like this just yet. I need to divide because this is undoing that multiplication. And the biggest mistake I see students doing is they realize they're supposed to divide, but they put in the sine, the trig function on top. And that's not, that makes a difference, right? If I have 4 divided by 2 versus 2 divided by 4, I don't get the same answer. So it does make a difference. So just think about what happens when you would cross multiply, and then I have to undo that and divide by the trig function, okay? So I put this in my calculator, and I get 35.727. So 727 is going to round up to 73. Okay, so just being aware of how to solve those proportions. Okay. Make sure you ask questions. Make sure you practice. This should start to become pretty natural and pretty quick at it. It shouldn't be something that we're struggling with. So if you need to ask questions, please do so.